There is a black hole at the very edge of what we can see, and by everything we thought we understood, it should not be there. Not yet. Not this early, and certainly not this big. It is one of the most distant black holes ever found, and instead of confirming the rules, it is quietly breaking them. It is forcing astronomers to rewrite the story of how the largest things in the universe are born. Start with the distance, because the distance is the whole problem. This black hole sits about 13.2 billion light-years away. Light is quick, but it is not infinitely quick. So looking that far out into space means looking that far back into time. The faint glow reaching our telescopes tonight actually left this object when the universe was only about 3% of the age it is now. That works out to barely 500 million years after the Big Bang. In cosmic terms, that is the newborn universe. The very first galaxies were still flickering into existence. Stars everywhere were young and blue, and yet, tucked inside one small early galaxy, there was already a fully grown giant. A black hole that had no business being that large, that soon. To feel why that is so strange, you need to know how astronomers thought black holes were built. For decades, the story was slow and patient and tidy. A massive star, many times heavier than our sun, burns through its fuel over millions of years. At the end, with nothing left to hold it up, it collapses under its own crushing weight. What remains is a black hole a few times the mass of the sun. A seed, small as these things go. Then that seed spends the next billions of years eating. It pulls in gas and dust, and any wandering star that drifts too close. Slowly, across the long dark stretch of cosmic history, the seed grows heavier and heavier. Given enough time, it climbs from a few times the mass of the sun to millions of times, until it becomes the supermassive giant that anchors the heart of a galaxy. We have one of those giants ourselves. At the center of the Milky Way sits a black hole about 4 million times the mass of the sun. It is enormous. It quietly holds our entire galaxy in orbit. And the key word here, the one that matters for this whole story, is slow. It took an immense span of time to reach that size. Because there is a speed limit on how fast a black hole can grow. It sounds almost absurd that something so hungry could be limited, but it is. As gas spirals inward, it heats up and blazes, throwing out light and pressure in every direction. Feed too greedily, and that flood of energy shoves the surrounding gas away. The black hole, in effect, blows its own dinner off the table before it can finish. So even eating at the absolute maximum rate physics allows, a small stellar seed needs a long stretch of cosmic time to reach millions of times the mass of the sun. Hundreds of millions of years at the very least, usually far more than that. Patience is built into the process. There is no shortcut, or at least there was not supposed to be. And that is exactly the time this early black hole did not have. 500 million years is simply not enough. Start it as a small seed at the birth of the first stars. Let it feed as fast as the laws of physics will permit, without a single pause. Run the numbers forward. It still should not be a giant yet, but it was. That contradiction is the entire mystery. Put it in human terms for a second. Imagine walking into a hospital nursery and finding, in one of the cribs, a fully grown adult. Not a big baby, a grown adult, decades old, resting in a room full of newborns. You would not assume that one simply grew quickly. You would know instantly that something about the story was wrong, that this one did not begin the way all the others in the room did. That is roughly the situation astronomers found themselves staring at. The object has a name, UHZ-1, and finding it took aiming two of the most powerful eyes humanity has ever built at the same tiny scrap of sky. The James Webb Space Telescope, which drinks in the faint infrared glow of the early universe. And Chandra, an X-ray observatory that catches the high-energy light a feeding black hole screams out as it devours gas. Even together, they nearly missed it, because the object is so far away and so faint. So astronomers borrowed a lens, not one made of glass, one made of gravity. A huge cluster of galaxies happened to sit in the foreground, directly between us and UHZ-1. The sheer mass of that cluster bends the fabric of space, and any light passing through it gets bent and magnified along the way. It is one of the strangest tools in all of astronomy. A natural magnifying glass, built from nothing but the weight of galaxies, focusing light that has crossed almost the entire age of the universe so that we can finally catch it. Without that lucky alignment, this discovery would simply not have been possible. We would have looked straight at it and seen nothing. And when researchers finally measured what they had caught, the numbers refused to behave. This was not a modest seed still working its way up the ladder. The X-rays told a very different story. UHZ-1 was already feeding hard, and it was already massive. Not a little ahead of schedule, not a comfortable margin. It was wildly, almost absurdly ahead of where anything that young had any right to be. By some estimates, the black hole weighed as much as every single star in its host galaxy combined. Sit with that for a moment. Normally, a galaxy is mostly stars, with a black hole at its center that makes up only a tiny sliver of the whole. Here, the balance was broken. The black hole rivaled the entire galaxy wrapped around it. The monster was as heavy as its whole home. A slow seed cannot do that. There is no honest way to start small and grow that heavy in the time available. Every model that begins with a single collapsed star comes up short. So astronomers were left holding a stranger possibility, one they had wondered about for years, but rarely had evidence for. Maybe this black hole was never a small seed at all. Maybe it was born big. That is the idea UHZ-1 supports. Instead of beginning life as one collapsed star, an enormous cloud of gas in the young universe collapsed directly, all at once, straight into a black hole. It skipped the star entirely. No slow burn, no supernova. Just a vast cloud folding down into darkness and emerging, on the first day, already tens of thousands of times heavier than the sun. Astronomers call these heavy seeds, or direct collapse black holes. They begin their lives already massive, with a head start so large it quietly erases the timing problem. Begin as a giant, and you no longer need billions of patient years to become one. You are simply born across the finish line, while everything else is still learning to walk. UHZ-1 is one of the first strong pieces of evidence that this actually happened. That the early universe had a second, faster, heavier way to make black holes than anyone could confirm before. And if that is true, then the family history of the giants at the centers of galaxies suddenly has two branches instead of one. Some of them perhaps did crawl up slowly from small dead stars, exactly the way the textbooks said. But others may have been born already enormous, seeded by clouds that never bothered to become stars first. Two utterly different origins, ending in the same kind of monster. And we are only now, with objects like this one, beginning to tell the two apart. And UHZ-1 may not be alone. If the young universe really did build black holes this way, then there should be others out there. Other overweight giants hiding in the first few 100 million years, waiting for the right telescope, pointed through the right lens, to finally give them away. That is exactly what astronomers are now hunting for. One strange object is an anomaly you can argue away. A whole pattern of them would rewrite the textbook for good. And all of it hangs on faint light from a single object, bent through a cluster of galaxies, caught by two telescopes working together, showing us a moment almost at the beginning of everything. One black hole, far too big and far too early, quietly rewriting where the very largest things in existence come from. There is one last thing worth sitting with. What we are seeing is not how UHZ-1 is now. It is how it was more than 13 billion years ago. In all the time since, it has kept going. It has grown, or gone quiet, or merged into something even larger and stranger. The universe did not pause while its light crawled toward us. We will never know which of those it became. The light took the entire age of the universe to reach us, and the object that sent it is long past. In a real sense, we are watching a ghost. A snapshot of a monster that was already a monster, back when the universe had barely begun and had no business making one. Too big, too early. Impossible by the old rules. And in science, when something impossible is sitting right there in the data, refusing to go away, it usually means the old rules were only ever part of the story. UHZ-1 is the part we missed. The universe is stranger than you were told.